Good morning and welcome to tomorrow's packaging materials. The world has changed since February. We adapt to new situations and rethink the way we work, the way we produce, the way we deliver, and the way we consume. And that's also why we are in a webinar today, not a physical seminar. Now my question is it also now that we together take the opportunity to rethink packaging, the value of packaging? Packaging has attracted some negative response, specifically in the last few years. But we use packaging for a reason. And some of our members say packaging should save more than it costs. We should actually switch slide, which I forgot. Now you can also see who we are at the stage. Packaging, as I said, we use packaging for a reason. And some of our members say packaging should save more than it costs. Packaging simply serves a valuable purpose. And now could be the time to reevaluate it. My next question is, how will the world look in 6 months? Will we experience a V-shaped economic comeback? Will we continue to work and consume in new ways? We don't know. What I know is that I, together with my colleagues at Packbridge, we want all of you in the packaging ecosystem to succeed in meeting the demand for increased growth and sustainable development. My name is Marie Malmberg Lavsen, and I'm the CEO of Packbridge. Packbridge is a non-profit member organization and part of the Swedish innovation system. And we are a cluster for the packaging ecosystem, connecting businesses, academia, and the public sector. And on the slide you see now, I hope, you see some of our business members. We integrate the entire packaging value chain, from raw material producers, machine suppliers, designers, converters, brand owners, retailers, recyclers, etc., etc. And that is also one of the main reasons why our members choose to join our network. Here you can also see some of the university members or research institutes and also partner organizations. We also do trend monitoring, and we share fact-based information in our network and also to external stakeholders. For example, the Swedish Government Office or the Swedish Office for the European Commission. And we involve our members in innovation challenge-driven projects. For example, how can a packaging material or a packaging machine contribute in reducing food waste? We facilitate physical and digital collaboration and competence development. And we do that in seminars or webinars as today. And we run workshops. We have some topic-driven networks. And we also have a conference, an annual packaging conference, Top Packaging Summit, which is the 24th of November this year in Malm. Together, we are stronger. And that's also why we choose to collaborate with Material Business Center. And I introduce you to Carl Malm.
Thank you. And I'm representing Material Business Center, an initiative run by Innovation Skåne. With the heavy investments in these two materials research facilities, we now want to build the best ever business environment around them as well. So the best environment where to start and run your new business based on materials technology. So we are running a startup community, a bit over 40 companies at the moment. also the best environment for established companies to be in or to reach out to, because this is where you solve your materials related challenges. And I'm really happy with that we're running today's event together with Maria and Packbridge. First, it was intended to be a physical meeting, but we decided to run it as a webinar. And I'm really eager to see what new possibilities this will bring. And I'm so happy that I guess we're about 160 attendees today. That's impressive. Thank you to my colleagues who have organized this event today, Malin, Elida, Erik, and also Lars. Thank you, Marie, Olof at Packbridge. Thank you to today's presenters for accepting this, challenge of running it digital. Thank you for Altitude Meetings for helping us out with the technical stuff with running this. And also heading Altitude Meeting, Yasemin, Ada Modéer. You will also be today's moderator. So welcome up.
Thank you so much. Thank you for having this event. Thank you for having giving us the opportunity, all of us, to be part, even though we can't gather as we saw on that slide just recently. But you are all there. I can't see you, but I would love you to just do a wave or whatever, so I can understand that you are with us. We have, as Carl just said, I think around 150, 160 people participating or on their way in. I don't know if they got stuck in some coffee thing or whatever you do at home nowadays, but warm welcome to all of you. It's going to be a really interesting day here. We're going to have taking part of a lot of interesting presentations, and I think it's so good to actually not just concentrate on one issue right now, but rather on things that will lead to a better world in the future, because there is a future and we need to talk about those important things, even though we have another crisis going on besides. So I think this is a great opportunity to take part of really interesting new thinking and innovations. So warm welcome to all of you. I will just lead you through some parts of this day. Since we are here digitally, I will not see when you are raising your hand or wanting to say something. So please use the possibilities to actually write down your questions, your comments, whatever you have. The chat is a great way to actually interact, and you can actually get answers from the other participants. So in the below on your tools below on your computer, usually you have something called chat. Use it, and during the whole session today, we will bring them up to try to answer them after presentations when we have had the speakers coming, having had their presentations, but we will also actually keep them and be able to come back to you later on and answer those questions. So please use that. Don't be afraid. If you want, I think it's a brilliant idea to put on your camera. For you, on the other side, you can also choose yourself how many you want to see if you use the gallery view, and you can actually see all the participants that are using the camera, and you can start talking to other people. I don't want you to kind of disappear. You are going to concentrate on the presentations here, but you can see others that are joining the meeting as well. So instead of a coffee break, you can see them and just holler. Use it. Use your imagination, and please use the mute button. So we can't have 150 people starting to talk. So that's a little bit about how we're gonna use this new great opportunities of being digital. So this is a little bit about the agenda today, or not a little bit, it's the agenda. We're going to have presentations, we're going to have coffee breaks. we're going to have actually a coffee break with the digital mingle. So we're going to divide you into groups where you can talk to your neighbors or whoever. And we're going to have some Q&A in the end. And as I said, you can use chat during the whole session here today, and we will bring them up. So just to get you on the mood, we want you to now use the chat and answer the question, where are you located right now? And I mean more geographically, not in which room you're in. So just bring it on. Which part of Sweden are you in? Or you maybe not even in Sweden. This is the good part of having it digitally. You can be all over the world and actually joining us. So let us know. Oh, we have Latvia here. We have Lund, Älmhult, Kungälv. We have Torekov, Småland, Bunkeflo, it's close, Svedala. Bring it on. Stockholm, Lund. This is really good. Dalby, very good. You know, this is, if you see the chat, it's really interesting. We've noticed in a lot of these meetings that we actually have so much more people joining us from all over both Sweden and abroad. So really see this as an opportunity to actually bring people on board that wouldn't maybe have had the possibility to join if we had had it here physically. I'm not meaning that physical meetings are bad. It's just this is a good addition to it. So the next question we will bring up is going to be a little bit more complicated for you, maybe not complicated, but now you're going to get a poll into your, hopefully into your computers, and we want you to answer these. So which materials holds the best innovation potential for your company? So please answer this question and submit. So do we have answer? Can we see, can we get it up in the, can you share it? So actually we have 70% of everyone has actually answered, even more, maybe I can't count this fast. And the winner is fiber-based materials with recycled. So, this is great, isn't it? So a big applause to everyone pressing the right button. All right. So to this, I just want to applaud you as well, because you have you know, passed the test in being interactive here. First speaker. So actually introduce us to the subject a little bit more, I would like to introduce Katrin Molina-Besch, Associate Senior Lecturer at Lund University, and she will talk about how to life cycle assessment. So Katrin, are you ready?
Yes. Yes, I'm ready. Good morning.
Good morning. How are you?
Do you want me to share my screen now? Yeah.
Yes, please.
Okay. Does it work?
Yes.
Yes.
Absolutely.
Okay. Great. Yeah. Good morning. My name is Katrin Molina-Besch. I'm a researcher and teacher at Lund University at the Division of Packaging Logistics, and that's at the Faculty of Engineering. And yeah, why am I here talking about life cycle assessment? And yeah, we also changed a bit the title. It will be about food packaging with reduced environmental impact and how to make the right choices. But I will talk a bit how you can use life cycle assessment for this and what to think about. Why am I talking about this topic? That is because that is my main research area, and in end of 2018, I have defended this dissertation about packaging development for sustainable food supply chains. So when we talk about packaging and its environmental impact, most people ask this kind of question: which type of packaging material is best for the environment? And maybe also some of you would hope that I would answer this question. But unfortunately, it's a very difficult question. In a way, it's also the wrong question, because you can't say which material is always, under all conditions, that is the best one for the environment. And for those of you that work with packaging, it's probably obvious that it depends on what type of product are we talking about, and also what type of supply chain are we having. Is it a local context, a global context, and what are the infrastructure for transport and storage, and especially if we're talking about food packaging. So unfortunately, I will not be able to answer this question, but I will hopefully enlighten you a bit or tell you some new things about how you can look at the environmental impact of packaging that will help you in the future to take the right choices. So if one thing that is very important if we talk about the environmental impact of packaging is that it actually has two different types of environmental impact. So if we take the example of a beverage carton, and we say, okay, on one hand, there's its direct environmental impact. That is what most of us are very familiar with, or what we think about. That is all the environmental impact that is caused by that we have to produce a packaging material, and we have to take resources for this. We have a factory usually for producing packaging materials that maybe has water emissions, air emissions, and so on. And then we use the packaging material to form a package, to fill a product. But then at a certain point of time, the product will be used up and we will have the packaging material left. And in a good, or in the best case, it will be recycled, sorted correctly and recycled. And then it has a lower environmental impact at its end of life. But if the consumer is not sorting correctly, or if they are in a country where there is no recycling system, it will either go to incineration or landfill and have an environmental impact there at its end of life. So this is the direct environmental impact of packaging. But at the same time, packaging also has an indirect environmental impact. And that has to do with the fact that the package has something inside. So the package is together with the product inside in the life cycle of the product and influencing a lot how the environmental impact of the food product inside will be. So here are just illustrated the most important influences that packaging have. The first one is that packaging, or the choices we make about packaging, have an impact on the transportation efficiency and thereby also the emissions and the energy use from transportation. For example, due to the shape of the packaging and also the weight of the material. More or less product will fit, for example, in a truck or container. Then packaging has also an impact in most cases on how we can store products, for example, whether we have to chill them or not. And then a very important thing is that food packaging has also an impact on the amount of food waste, both in the supply chain, for example, in storage and transportation and at retailers, but even at people's homes. So how much of the food that will actually be eaten or will be thrown away is influenced by the package. So this is very important to have in mind. And based on this, when you do research about packaging and how to reduce its environmental impact, and you look at different models, how to do this, there are three main areas that different researchers and people working with this also in industry highlight usually. And that is that packaging, or good packaging, should contribute to reduced food waste. Secondly, that packaging should contribute to efficient transport. And lastly, that also the packaging material, the direct environmental impact of packaging should be minimized. So if we go through those three areas quickly, just to look at what is the things that you should do in order to address those three areas. So which types of packaging solutions contribute to a reduction of food waste? The first one, very obvious, that packaging should protect the food. But it's not only about barrier properties and protection in that sense, but also the size of packaging, choosing the right size based on the needs of the consumer. Then all these features that affect the user friendliness of packaging have an influence on how much waste we have, especially in people's homes. And then also the graphical design, the information that is on the packaging can have an influence, for example, on how people store food and how quickly they use it up, and thereby having an impact on food waste. Since this is a material about packaging materials, obviously I just wanted to highlight that if I had to pick one of those areas, it is the barrier function, the possibility of packaging materials to prolong the shelf life that probably has the most important impact from a material perspective in that area. If we move on to the second aspect, transportation efficiency, it is the most important thing is to maximize fill rate of packaging system, and there it is both volume and weight optimization that is important, depends a bit on what type of product we are talking about. But as I mentioned before, packaging can also have an influence on the cooling needs and thereby reduce the energy of transportation. And then it's also about optimizing bigger units to have the lowest possible amount of units that we are handling to reduce the energy. Here I just wanted to highlight that you might think from a material perspective that it's always packaging weight that is like the lowest weight is the best. And I mean, that is a good thing to have lightweight packaging materials. But the problem is that many food products are actually, in a transport perspective, it's limited by volume. So thinking even from a material perspective, how can we have materials that also can help us to have volume optimized packaging systems would be a good thing, because there is a lot of potential to improve it in the future. Then if we move on to the direct environmental impact of packaging, that is what you're probably more familiar with. There, the most important aspect is to use the right amount of material. So we talk about optimization of material use, just as much material as is needed to protect the food product inside. Then with all the talk about circular economy and so on, obviously it is about looking at the end of life of packaging materials and developing materials that work in collection, sorting and recycling or reuse systems. And then it's always important to consider that there are, in different countries, there are different systems, and that if possible, you should try to adapt packaging solutions to the situation that actually are there in different markets. And then the last thing is that it's not only choosing a material that has a low environmental impact, maybe in an average sense, but also looking at your particular packaging material supplier and how they actually work with, for example, sustainable production and what type of raw material sources they have and so on. Because there are, if you look at LCA data, there is not only a big difference in, for example, the carbon footprint between different types of packaging materials, but even between different suppliers. So, for example, a carton supplier can have a different carbon footprint depending on which one you use. So let's not forget this kind of detail. But then if you've worked with packaging development, you're probably familiar with that there are many different requirements in packaging, and it can be very difficult to find a good balance. And even if you now here, we just focus on the environmental impact. So we are not even considering things like costs and production requirements and marketing requirements and so that are so important for most of you. But even if we're just trying to do the best choice from an environmental perspective, we will quite often run into conflicts between those three areas, that if you try to do one, you will do less of the other, and then you don't really know what to do or what to prioritize. And then LCA is actually, or looking at LCA results, is a possibility for how you can find a way how to prioritize. So I just wanted to illustrate this by showing some examples of life cycle assessment results from food products and their packaging solutions. So the first example here is the carbon footprint of the mozzarella cheese, including its packaging and the complete life cycle. And here you can see that it's the production of the milk that has the biggest impact, and while the packaging has a very small impact. So for a product like this, if you run into a situation where you don't know, is it worthwhile maybe to improve the packaging to reduce the cheese waste, for example, in the household, or not? If you see a LCA result like this, you can be quite sure that it will be probably worthwhile, because maybe increasing the red part a bit will not affect so much if you can reduce some of the green share here. But unfortunately, it's not so simple that things always look like this. For example, if you then look at a carbon footprint of a tomato puree in a glass jar, and now I'm just showing extreme examples, so it doesn't mean that glass results will always look like this. But just for illustration purposes, I choose this example where you can see that you can also have quite an opposite result, where the packaging has a very big impact, especially if you also consider that part of the blue, the transport impact, is also due to a rather heavy packaging solution. So if you're in a situation like this, it's probably more worthwhile to look at the specifications of the packaging solution and try to reduce its impact somehow. I mean, not forgetting about that you still want to protect the tomato puree, but yeah, just for prioritization purposes. And then a third example, just to show that it can look even different, and also consumption phase, the yellow share here, can have a big impact. For example, if you look at bread in bags, and there's a mixture of plastic and paper bags used in this study, you can see that here also, the ingredients have a big impact, and packaging has a small impact again, as in the first example, but also the consumption has quite a big share. And this can be even higher for some other products, like for example, pasta or potato products and so on, where there's a lot of cooking and energy use in the household. So that is an area that people don't think so much about. So now I've shown you, based on these examples from life cycle assessment, that you can, by looking at LCA results of products together with packaging, you can find ways, or it can help you in these kind of trade-off situations to prioritize and know which direction you should probably focus on. But there is one complication. So I wouldn't be a researcher if I wouldn't raise that there's some problem with this, that it's not that simple. And that is, if you look at those three different areas, then they are actually contributing differently to different environmental problems. So the most important areas of environmental concern is different between those three areas. So for example, if we look now at what are the big issues related to food waste, the big issues are connected with the production of food, and if we are producing too much food, then we have more food than we actually need, because we are wasting 1/3 of it. Then we have all these problems with biodiversity, with the fertilization, phosphorus and nitrogen cycles, and land use. These are really big problems that also will continue to increase in the future when more people are on the planet and we need to produce more food. While if we look at transportation and the most important environmental impacts connected to freight transportation, then this is climate change and human toxicity, two examples. And if we look at the direct environmental impact of packaging, the impact of the packaging material itself, things that are mainly discussed is actually climate change, resource use, and also the waste problems, especially plastic leakage, a big issue right now. So if you compare those three, you see that there are differences between them. And if you want to do this contribution analysis that I talked about before, you usually have to choose 1 or 2 or maybe maximum 3 indicators. And then it will be difficult to select indicators that are evenly important for all 3 areas. So in the long run, to really develop good packaging solutions for the environment, we somehow need to find ways to avoid the trade-offs. And maybe some of you can help to do this in the future. So just to conclude this short presentation, if you do life cycle assessment or other type of environmental assessment of packaging, it is so important that you always evaluate the environmental impact of the complete packaging and product system. So don't optimize packaging material in isolation from the products that it is supposed to protect. And if I can make a wish list for how packaging materials for sustainable food supply chains should be, they should protect food to minimize food waste in the complete supply chain, and they should obviously utilize the lowest possible amount of raw materials, so they should be resource efficient, and they should function well in the post-consumer sorting and recycling systems on the markets of their application, and also contribute to transport efficiency in all parts of the supply chain. And since this is currently, with most of the solutions that we have at the moment, very difficult to fulfill, maybe we need some new material development of new barriers that help us to avoid these trade-offs. And I don't know how I'm time-wise, but this is what I had thought to present. I hope I kept the time.
Yes, very, very good. So actually, we have some quite some time for questions, and I directly have a question on myself, and I think it's also coming from one participant. It's, you had that example of bread and consumption of bread, and the question came up here. Make an example of the bread bags. What energy is used in the consumption part?
Yeah, that is, I think it's both storage, like freezer or refrigerator, because people put bread there because otherwise it turns bad too quickly, especially if the portion is quite big and if you're living alone. And then if people put bread in the freezer, for example, they need to heat it up again before consumption. So then they put it in the oven or electric toaster or something. So this combination of first storing it chilled or frozen and then heating up again before you use it, which is very inefficient in a way.
So we have some other questions I have here from Lavsen. Often it can be difficult to get LCA data that is specific enough. Any reflection on this?
I think I mean, I agree, and I understand that for companies, you cannot do LCA all the time on all your packaging solutions and products and so on, especially if you're not such a big company. But I think, like this example that I show, like how you can look at contribution analysis, get a feeling for what is big and what is small. Maybe you don't, I think in most cases, you don't need to do a specific one for your particular package in your particular product. You can, the ones that exist give you often a good feeling, at least to make these priorities. Then it doesn't have to be so specific. It still can give you a direction. And therefore it's important to know how is the relation between packaging material and transport and my the products that I commonly pack with my solution, like knowing this relation. I think not all companies know this.
And this, I mean, when I hear you explain this, and in this case towards the companies, organizations, how as a consumer, how are we supposed to be? I mean, it's really complex. You do believe something, obviously, you know, everything from buying closely produced vegetables, for example, but looking at your data, it's much more complicated. So what is your advice to consumers on this? How do we think?
Yeah, for consumers, I think it's much more important because they have much less data compared to the companies. So they don't know, for example, how the supply chain looks. They don't know how the transport conditions are at different parts, and they even don't know what kind of materials are that work for certain kind of food products. I mean, you have to have some knowledge about this. So they might think, why do they pack this in plastics it's not necessary, but it might be necessary to have a certain shelf life. So for a consumer, it's much more complicated, and I don't know. I mean, I don't think it's a very good idea to select products solely based on the packaging solution, because it should be, it's the whole thing. The product should have a low environmental impact and be in a package with a low environmental impact. So I usually focus on what is inside and not so much on that is just the packaging. And then, as I showed before, in most cases, it's the product and not the package that has the biggest impact.
So actually, it could be a good thing to have when you do the branding or whatever, to actually write the whole story and actually bring on all the aspects to the consumer, maybe.
Yeah, exactly. To explain.
So we have some more questions coming up here. What is the impact of the feedstock for producing the packaging plastics?
I mean, if you look at the life cycle assessment of only packaging without the product inside, to see more in detail how it is spread exactly between the end of life and the production impact. And if you look at fossil resources as an impact category, then the feedstock has quite a big impact. And the energy use. For example, if you look at the carbon footprint of a plastic bottle, the biggest impact is the production of the bottle, and some of this is also the feedstock. Then that is also why if you have incineration with energy recovery and so on, that then from a carbon footprint perspective, the plastic packaging doesn't look so bad, especially if you if you're anyway in a system that is burning other fossil fuels for electricity or heat. So it has quite a big impact. It usually has a bigger, especially if you look at indicators like carbon footprint, then the production and the feedstock is more important than the end of life impact.
Again, quite many thoughts to have in your head at the same time. So the next question, which new barriers seems most promising?
Yeah, I don't know. I think it's difficult. I think there's a lot of, which I think is a good development, looking at new barriers for fiber-based packaging. Because that's often a problem that if you're combining fiber with plastic, that then at least the plastic part, but it doesn't have a problem for the fiber recycling, but the plastic part, since it's so thin, is economically not feasible then to recycle. So doing something about this, trying to find solutions is important. And then, overall but I don't have any good examples of what are good. I think there's a lot of development on more renewable barriers that could achieve the same as the ones that are now fossil based, but it's difficult to achieve the exact same barrier properties. It's not easy.
And again, I want to address the audience here. If you have any comments to the questions that are raised, or have any other, adding on to the answers, please use the chat, and we can have that later on to gather information about around the different questions. Next questions. We have a lot of questions here. Katrin, any examples of packaging that minimize cooling requirement?
Yeah, very true. I mean, you can argue about whether the product is still exactly the same, but a very famous example is, for example, when you switch from chilled milk to UHT milk, that then both in the whole storage and supply chain transportation, you don't need to cool the milk anymore, and also, at least until people open it in their home. And that is, if it's a long supply chain, that can make quite a difference from an energy perspective. But I mean, you also have to treat the milk and so on. It's not only switching the packaging material.
Mm-hmm. And again, audience, if you have a ongoing question to the answers to your questions, so please don't hesitate to add if that was enough. For example, for this cooling requirement question from Ranji Hatti Kaul. If you have any comments on the answer, please let us know. We have another question here. Do you think it is common that complicated laminates are used instead of recyclable PP or PET, even though it's not necessary in food industry? A very long question there.
I mean, I think the reason why we're using laminates is because especially if at the time where maybe you solely had a cost focus, it was the most efficient. And even if you only look at energy and carbon footprint, it still can be very efficient to use a combination, because then you have much less material that if you use a mono material, usually need to have a thicker material, and you use more resources for this. But it's complicated because the question is, do you only want to look at carbon footprint, for example, or energy use, or do you want to include other indicators that more have to do with what is the environmental impact of landfilling or incineration and so on, that then you get into these trade-offs between different environmental impact categories. So I mean, there might be, I think a lot of companies are now working with this, seeing where can we remove complicated structure and simplify it to also increase the recycling. So I think wherever it's possible, it will be done in the coming years. But then there are some applications where we really need to find new types of barriers to make it possible, I think.
Would you say, in addition to this, would you say is, because again, you have been mentioning in a lot of times here that it's quite complicated to get the full picture and the balance and so forth. What would you say is the biggest hinder for actually getting the whole picture, the whole cycle, or whatever? Is it a communication, or what would you say is the main reason for that?
Yeah, I mean, it's in a way one reason. I mean, one reason is that simply it's complicated and not easy, and people usually want simple answers. Another problem is that it's not so easy to sell it to consumers either, because consumers also want easy answers, and it's much easier if you would tell them you should always buy fiber-based packaging, or you should always buy a certain type of plastic, and then it's good for the environment. That would be so much easier. But if you say it all depends, and you have to look at this and you have to look at this, then it's not really an easy thing for marketing. And then if you do a change to your packaging from an environmental perspective, and maybe this requires you to make an investment, you also want to be able to communicate it to the consumer and get a benefit for what you have done. But that is not so easy, and maybe the one that would be best for the environment doesn't look much better for the consumer. And then how do you get this? So that's one issue. And the other issue also, to do it good, to make these very comprehensive studies, also people in the supply chain need to work together, because no one has the knowledge about all this in most cases. Like the retailer has some knowledge, the packaging producer has some knowledge, the food producer has some knowledge, and ideally they should all work together from the beginning to optimize a packaging system. But in most cases, one of them that is leading the packaging development, and they are not working as closely together on this aspect.
And would you say on this, it's obviously a lot of talk about having much more locally produced goods at the moment, obviously, and we've had that discussions so many times before. Should you buy locally produced, or is it better to buy the ecologically produced, wherever it comes from? I do understand that it's not an easy answer to say yes or no, but what would you say in that on those comments?
Yeah, again, it's probably an it depends answer, because it can be, for example, if you can't produce a product here because of the climate, so you have to produce it in a greenhouse, then most greenhouses are fired by fossil fuels. Then, for example, the carbon footprint and the energy use for a tomato produced in Sweden is much higher than if you take one from Italy or Spain and transport it here in an efficient way in big orders and so on. So it depends. But if it's a product, I mean, then you can get into this whole discussion about, but maybe you should eat more in season, so then you can only eat what you can provide from here.
Naturally.
But then for countries like Sweden, it's quite of a boring, maybe, I don't know. For vegetables, maybe is fine, but fruit is a lot of apples, or I don't know.
Okay.
Yeah.
So we have a question here from Edward Hall. Any thoughts about PHA? I don't even want to pronounce, say the whole word, what it is. So please read it in the chat for you guys who look at the, because I'm not going to be able to pronounce it. So any thoughts about PHA as a barrier? He missed a little bit in the beginning, so if you have already mentioned it, but I don't think you did. Maybe you, so yeah, any thoughts about this? Anyways.
Yeah, no, I'm, so in the research that I've done so far, I have not been in detail into different kind of biopolymers and so on. So I cannot say, but hopefully in the future we will get more into this, because we will in September be involved in that. There's a big research project at Lund University called STEPS that is about the development of renewable bioplastics. And I think that they have looked at it, and we will also have a task focusing on packaging. So maybe this will be something that we will explore more, and then I can tell you more in 1 or 2 years, hopefully.
So Edward, have contact with Katrin
Yeah.
on later on. And one last question here. No, maybe two. Would a fairly simple labeling of the LSC stages performance be a benefit?
Yeah, I don't know. I think many consumers are still already confused with all the labels we have for health purposes, for example, and then we have labels about organic food, and then we have, so just adding another label might just be confusing. And then, for example, exactly, would it be a label for the product and the package, or just the package, or how do you do this? So it's, I don't know, in some cases maybe, but it's not so easy, and you could only also be a bit overwhelming for many consumers to understand it. And also it is a lot of work for, I mean, you know that in the past, for example, retailers like Tesco, so they have promised to put carbon footprints on all their products, but then after some time they realized how much work that would be, and you have to, I mean, even to do it once would take a lot of time, and then the supply chains are changing all the time, and they buy, for example, bananas from different places, and then they need to calculate the average that changes over the year and so on, and then you need to update it every 2 years, and so it's not an easy fix. So I don't know if it's worthwhile. I'm more into that the companies, for their internal decisions, to make good decisions, they can work with LCA, but I don't know if it's a really good thing for communication with consumers.
Okay. I think we have time for one more question, and that is, how do you think COVID-19 will affect the self-sufficient discussion?
About producing more food here, or?
Yeah.
Yeah.
Yes.
I don't know. Maybe, but on the other hand, I don't know. I think people are very much longing to a life how it was before. So if it's possible, and it's quite common that people also, I mean, right now we might all think, yeah, we will do more conferences and we'll not travel so much again. But I don't know. On the other hand, we have enjoyed a lot of this. So I don't know if it really will make such a big difference, but maybe it will be something in between. And then maybe it will also lead that we will try to produce more food here. But then on the other hand, it must also be, we shouldn't do it just for the purpose of doing it here, but also look at how efficient is it actually, and what does it mean for the environment that we are having here.
Yeah. Actually, okay, let's try one last, because we have actually one more. So it's, what is your view on plastics from an overall life cycle perspective? It's a longer question, but I just take the end of it.
Yeah, I think it's, if you look at food packaging, it is a material that for certain foods, it provides the best barrier properties, or very good barrier properties, and also usually don't need that much material, so you can also, from a transport perspective, it's a good material. But then the big challenge is the end of life. that I think we need to do something about. And how can we avoid this trade-off? How can we have materials that have good barrier properties, but that are still protecting the food? That's the big challenge. And if some of you can solve it in the future, I think that would be a good thing.
Thank you so much, Katrin. I think all of you have, we have had a lot of good questions here. I think you have a lot of knowledge as well among the participants. Please write, chat. You have the contact information to Katrin here on the last slide. So use that and add on whatever you have in your head. If it's not out there, we will not be able to take part of that knowledge. So please use the chat or whatever. I would like to welcome the next speaker here. It's Peter Edberg from Paper Province cluster, and you are an innovation advisor. So please, the screen is yours, and let us hear what you have in your pipeline.
Okay, thank you. Let me see. You cannot start screen share while the other participant is sharing.
Sorry, it's my fault. Here we go. I was so excited to hear you, so I forgot what to do.
Thank you. Let me see. So am I up and running?
Yes, you could use the presentation view in the yes, thank you.
That's correct, right?
Well, now we see your notes as well.
Oh, it's just strange. How do I get rid of those?
I think it's in visningsinställningar, maybe upstairs on the top. Yeah, that one, and you just use that one. Yes, the växla mellan.
Perfect.
Yes, perfect.
Hello, my name is Peter Edberg. I'm a project manager at the cluster organization Paper Province. And thank you, Packbridge, for letting me talk about this test environment we are building. The project is called FLAM. That is a name that works both in Swedish and in English. It stands for Fossil-Free Laminates. And shortly about Paper Province, we are located in Värmland, Karlstad, sunny Karlstad. We have 12 employees. We have several projects around 12 to 15. And we have a turnover at 24 million Swedish crowns. We started actually because companies had hard to find new competence. So we helped to make the forest industry more attractive to young people. And that's a challenge because the forest industry, I think we all believe, is the future. So this is pretty similar as Packbridge. We are working with meeting places and network. And we like to realizing the forest-based bioeconomy. And you can do that, for example, with the test beds. And we're not only working with the packaging, we also work with side streams from paper mills, and we work with wood buildings. We like building in wood.
Peter, I think there is your picture is really kind of outside the screen, so to say. I don't know if there's some kind of if you could change the settings or something.
Where do I do
this is always a bit complicated because I can't go in and look at your computer now. So
that's strange. I have the
if anyone has a, you know, again, if you have a solution to this, use the chat and we can see if we can.
What can you see now? Is it the two screens?
Yes, it's like the presenter's view, and we can, yeah, if you have the notes, we can see that. So let's try again.
I should do something.
The technical things, you know. Well, or you just go ahead. Okay.
Should I do like that now?
Yes, try that again.
Is that okay?
Yeah, it's a little bit outside on the left side corner, but it's okay. Let's go.
You can also check at the top. You have the view options.
Yeah.
You can choose fit into window.
Where is that?
High up in the middle. View options. Do you have that?
I think you need to exit again, don't you?
Oh, okay.
No, you can learn so much, like in doing this, you know.
In the picture. So up in the middle, you are viewing Peter Edberg's screen, or into the right view options.
Well, I don't see it.
Okay.
That's pretty strange.
Because the viewers can use that.
Okay, the viewers can use that, so we can.
You can fit it into the window.
Okay, we'll try. You go on, and we'll see if we can adjust it from here. And if you guys who are looking at it, and if it's a problem, you can probably adjust it. So I think you should just go ahead, Peter.
Yeah, thank you. We have around 112 members. It's large companies, as you know, Billerud-Korsnäs, Stora Enso, Nordic Paper, Rottneros. And we have a lot of producers of packaging material. But we also have a lot of consultants. And I think I go back to the project FLAM. It's always good to start with a problem that you want to solve. And here is the challenge. And I will not talk about the plastics and the ocean. I think you heard that 1,000 times. But interesting is that the packaging market today is the largest user of fossil-based plastics. 40% of all fossil plastic produced is used in packaging industry. And Sweden is today the 4th largest exporter of paper. And 50% of this volume is coated or combined with some form of fossil-based barrier material. So small Sweden can make a really big difference here. So I think we can take that challenge. And as you know, the grocery stores in Sweden will be fossil-free in 2030. And you have seen this. This is from Svensk Dagligvaruhandel, Swedish Food Retailers Federation. And how can you do this? This is scaring and challenging for companies. And to solve this in the best way, I believe we should talk to each other in the value chain. So I can tell you a little bit what a testbed is. I think the most of you maybe know it. But it's about a physical or virtual environment where companies, academy, and other organizations can collaborate. And the testbed should also be open to users outside their own organization. So for an example, McDonald's and Burger King and Stora Enso and Billerud-Korsnäs can test at the same week at the same test bed. That's good for the world. We need to solve things together. So the project was approved by Vinnova in October 2018. And Vinnova is Sweden's government agency for innovation, as you know. So the project will end in next year in October. Project budget is 14 million Swedish crowns. Here is the 3 phases. So we are at the end phase now, realization. I don't think I will talk so much about this, but we have seminars like this and learning more about different topics. I can also mention that one company in the project has used all 3 test beds already. I think I move on. This is one long sentence, but I will read it to you. The development of the testbed creates the opportunity to effectively combine paper with dispersion-based barrier coating and extrusion of bio-based plastics and printing in a combined and unique offer. So you think anybody want to join this project? Yeah. So we have 23 participants, and it's from researchers, cardboard board manufacturers, barrier materials, bioplastics. Brand owners is really important because they are putting the demands to us. Oh, it's a spot missing. Seelution. It's a company in the project who will explain a little bit about the new unique barrier for you after me, dog Tryggö. So here are the three physical places. Broby Grafiska in Sunne, it's a school for printing. UMV Coating Systems in Säffle. They are world leading in coating. RISE Stockholm, you all know, located in KTH and also Kista. There is an extruder. I will not talk about these locations anymore, because I think there are one thing that you like more than machines, and also me. That's meeting people. You remember when we could travel? This is a really interesting and where the project happens, when meetings in a value chain take place. And you can talk about, for example, regulations, customer demands, challenges. And next meeting should have been this Thursday at Karlstad University, talking about LCA. But that will not happen. I like to provoke sometimes by saying traditional fossil plastic is cheap and good for the purpose. Cheap and good for the purpose. That's our component. That's the challenge. Cheap and good, except for the environment. So, but when you talk to, for example, Löfbergs coffee, the coffee beans must smell and taste good as today. So if we make the best green package ever, but the coffee beans don't taste as well as today, there's no, we have no case. So that's really interesting. And I guess you know about all these things, but it's challenging. And sometimes life length for peanuts, for example, in 9 months. If we try some new solutions, maybe it's lower. That's a challenge. Katrin talked a little bit about food waste also, but this is of course interesting. I know a survey in US, many thought packaging was unnecessary and bad for the environment, but at the same time they didn't like food waste. That's it's a paradox. It's a little bit funny almost, because as you know, food has a larger carbon footprint than packaging material. And I think I will let Oscar at Scanfill talk about reuse and recycling later. Step by step, I think it's important, because sometimes if you aim at 100% perfect now, you can fail. And so in project like Flam, we are working with step by step. It's nice to win. So we take it step by step for tomorrow's packaging materials. And as always, you should be humble and work together in corporations. We need to strive. Yeah. I think is that 10 minutes with some technical issues, Yasemin?
Very, very good. Thank you so much. Again, I think you've mentioned it, and I just want to add on. I mean, what would you see is in this project the main challenges?
Well, there are a lot of challenges, but the most important is the participants strive and that they can take time to participate in the project. Because if a company has a lot to do, they normally, or some companies don't want to focus on these kind of projects and innovations.
And is a money issue as well?
No, it's not. I think every company in this project is at least putting in 40 hours per year, and some other companies a lot more. But I don't think it's a money issue. It's important to be innovative. So I hope they understand that.
That's good. And using you actually as a mediator.
Yeah, I do that.
Yeah, we have a question here. If a company has a unique bio-based or biodegradable polymer, it believes could be used as a coating, how can it utilize these? How can it utilize these resources today?
And today, yeah, the word today also.
Yes.
But we are building the test environment now, and it's a unique combined offer. But of course, UMV coating in Säffle is open today. So I can absolutely get Edberg the contacts to UMV.
Yeah, you're here, Edberg. You just go ahead. And with this, we will come back. I will just tell you all this. We will have a Q&A session in the end of this before lunch, and we will have opportunity to bring up more questions. So if you have something that you kind of just wanted to say as Peter, you will have the opportunity later on as well. But we have one more, and I will just take that before letting Dag on. So Peter, could you describe a little bit more about your material? How do you get the right functionalities?
Good question. This project is building a test bed, so we don't do new materials. That's not included in the project. But Seelution will talk more about this after me now. Okay.
So I think that was a great bridge to Seelution. So Dag, are you ready? I will stop sharing my screen, and Dag, the screen is yours. So bring it on if you want to share your screen.
Okay, thank you very much.
And I'm sorry, I didn't even introduce you. I'm sorry, I was just thinking that everyone knew who you were. But you're business development at Seelution, as we heard before.
Yeah.
And your topic is how to choose fossil-free laminates. So
exactly. Welcome. Just checking, do you see my presentation?
Yes, absolutely.
Okay. So I'm Dag Tryggö. I work as a business development manager with Seelution, and we are one of the participants in this this FLAM project, and we are also participating in other similar projects. And I will talk a little bit about our experience here from that type of projects. So there it is. Just for you to understand, so we are bringing to the table our barriers. So Seelution makes renewable barriers that ticking all the boxes for environmental friendly material. It's bio-based. It makes the packaging easy to recycle. It's compostable, and it has excellent barrier properties, bringing oxygen barrier, grease barrier, oil barrier, aroma barrier, to the packaging, and it's also heat sealable, and it's approved for direct food contact. And this is then applied by dispersion coating. So that's what we are bringing. But how do you make sustainable packaging? Well, it's not a direct straight road in our view. It's not a one variable equation, and I think this has been brought up by the previous speakers, Katrin and Peter. It's easy to focus for us having material. It's easy to focus on the problems that we solve and the problems that you might face using our product. But packaging is there are much more stakeholders involved. So to go all the way, I think these kind of environments that these pilot plants are bringing, and also other projects, is very important, because as we have heard, it is important to bring in the knowledge from several stakeholders. It's not only the paper mills with the paper, people like us that have the barrier materials that you coat paper or other substrates with. It's also having the brand owners who sets the targets and can prove prove the concepts that you are doing, that they are actually working in the real life. And the converters who have to be able to run the material that you're making. Of course, these pilot plants can help a lot for actually testing that what you have designed will work to produce. And you need it to produce material to make mock-ups and packaging. And we have also found that even the equipment suppliers need sometimes to be involved, because when you are making new things, and not necessarily are the existing equipment well equipped for handling that. And we see some challenges running through, for instance, the coating process or the packaging process, or even just handling the food in the end. That has an impact on the result, and it's good to bring in those stakeholders. So I think that is one of the things we have seen, that it's a good way to not focus only on your product, but actually on the whole chain, and that is needed to solve the whole, to make new packaging. We have also seen, we talked about a little bit here, that it's easy to, you should aim high, of course, but it's good to get to set some priorities, because if you say you have to have totally non-fossil, fully recyclable product, and the packaging has to be better or not worse than the existing packaging, and it has to be as strong, it has to be able to run through the same machinery without any investments or anything like that, then you are creating maybe too many hurdles. So it's important that you try to, working in the project, set what is the highest priority, and what is it that we in this project decide not to allow to change. And that could be varying in different projects, for instance, but that could of course be things like, we're not going to change the packaging machinery, but maybe we're allowed to alter it somehow. You could also say that, okay, we are looking for something that has to have at least 4 months shelf life, and not necessarily putting that it has to have 12 months or something like that. So I think not that you shouldn't aim for having the best you can, but not saying that, well, it's easy to kill a project by aiming, by putting too high, aiming a little bit too high, and then maybe you might fail. And I think we need to accept that going half the way could be a good start. And something else we have learned in working in this project, I think, is that it's good to allow for a little bit of a trial and error process. Of course, you make your design that you want to make, and in this FLAM we have been participating in building up a choosing type of paper and primer that you're using, what barriers that you will be using, how you will make the heat seal and so on, and you make your design. And then you need these pilot environments to produce paper and see that it fulfills, that you can fulfill all the targets that you have set. And then you go on, and we have been able here to test the runnability also in the filling and packaging environment, and see that the packing integrity is good and that the shelf life is good. But we have seen then that we face some requirements that we didn't identify from the start. And I think that is quite normal. And setting up projects is good that's something we have learned at least. It's good to allow for this and to think about this already from the start, and allow for some reiteration that you might have to go back and change something. That could be in the process, and that could be in the material you're using, or something else. But I think that is something that we have seen, that we have learned in this. And so to summarize a little bit, what we have seen is that bring in as many as the stakeholders as possible. Not all have to have the same role, of course. Some can have a more key role in the project, but it's good to be able to test the results with those who will be impacted from the packaging, and then be able to go back and see if you could improve those things that might still be remaining as a challenge. Yeah, that's what I wanted to share from our experience working in these projects.
So thank you very much, Doug. Please use chat. We have some minutes here for questions. And we have a question directly, I think. It's the barrier is biodegradable. Does it end up in industrial compost in the present Swedish recycling system? If not, what need to be changed in the system?
Yeah, this is going maybe more into the technical things. Our product is recyclable, but in practice, it's not economical to recycle our product as a barrier material. So what you actually do is that you want to keep, if you have paper that you're making your packaging with paper, and you want the paper to be easy to recycle. And our barrier has no negative impact at all on the recycling of paper. It could go into the normal paper stream. If you're outside of Sweden, that is quite tough for a lot of materials, but not for ours. In Sweden, in practice, where you put, packaging made with our barrier could go into the paper stream. But we have a stream in Sweden where you put packaging which has a mixture with more plastic, and we separate the paper from the plastic. So in Sweden, actually, it's more about maybe the fossil content than it is outside. But what we have seen, and I think what everybody should be accepting a little bit, is that the perfect solution might not be there. So I'm talking about our Scalax barriers here, but often, we started saying that that's so good, but in practice, we want the paper surface to be closed, which means that you have to have a pre-coating of some kind, and that might not be so easy to find a perfect pre-coating that is as good as our barrier. And then a lot of food needs to be protected against water or water vapor, and our barrier is not protecting against that. So again, there you also need to have something else, and that might also be some parts that are either plastic or fossil or both. And I think one should then, it's good if one have in mind that, okay, if the focus is recyclability, and then you can have as maybe a little bit less priority to have non-fossil or non-plastic. Then one can work with solutions that can go maybe from 40% plastic or 100% plastic to 8% plastic or so. And that might be a good way to start. But yeah, to the question, yes, our product can be recycled with the paper, but you don't make new barriers out of the barrier material. That's not economically feasible.
Thank you for that. And we have one last question here before we need to end this session, this part, and it's from Katrin. What is the renewable raw material used to produce the Scalax barrier?
Polysaccharides. So our barriers are made from plants.
Okay. So, and I just have one question. We were talking before when we preparing this seminar, and this both the complexity again, and that you have a lot of different stakeholders, and we were talking about this life expectancy for a product to hold for 12 months. Is that a big, I mean, how can we get around that to actually try new forms of packaging so we can, as a consumer, it's okay if those potato chips just last 4 months instead of 12, which seems like really gross when you think about it. Anyways.
Well, I think that since there's a lot of interest in this, I think the brand owners should realize that maybe they should have different packaging from different markets or for different customers, and those customers who are who don't need these long shelf lives don't necessarily need to get that package either, even though I can understand, of course, from an economical point of view, it's good to have one package serves all. But maybe we should accept that there will be more alternatives, and that, as you do with milk, you can buy the UHT milk, or you can buy the low, whatever it's called, low heated milk product, depending on your needs. And I think that should go for more products, that you don't always get the toughest properties if you don't need it. And that way you can reduce the impact on the environment.
Yeah. So thank you very much. We do have another question. I will leave that to the Q&A later on, and it is from Carl, so it's kind of, I can treat that question later. So, and thank you very much, Dag, for this really interesting presentation. We will move on to the next speaker here, and we will talk a little bit about trace and how to use blockchain technology and packaging traceability. So welcome, Patrik Ekdahl, Manager Platform Security Research at Ericsson.
Thank you very much. Okay, good. I'll just try to share this like that. Okay.
Yes.
It seemed to work. Good. So, well, thank you for having me here. I'm sort of the odd one out here. I don't spend my time researching packaging material at all. But I have looked at blockchains a bit, and also tried to come up with good, interesting applications for blockchains. And let me see. So what I'm going to talk about, it's a bit about the fundamentals of blockchain. So this is maybe one of those talks that gets you out of your comfort zone a bit, but hopefully also inspiring to learn new things about blockchains. So we'll talk about the fundamentals, how it works, different kinds of blockchains. And the second part, then I will sort of try to reflect on things that I see could be useful in the logistic settings, or what you need to think about in the logistic settings if you're thinking about using blockchains for tracing or tracking. So this, to the right here, you see a sort of a decision diagram if you really need a blockchain. And to be honest, in most of the cases, the answer is no, you don't need a blockchain. So it was a couple of years ago, it's a very hype word and a very hype new sort of technology. But I think in the end, there are very few applications that really, really benefit from using a blockchain. And I will try to explain why this is the case. So just starting off, very brief overview of how it works. There's basically three ingredients in a blockchain. It is this all the workers that do the build the new blocks of the blockchain and validates all the inputs and communicates the different inputs to each other, because all the workers of the system has to have a common view on what's in the blockchain. So that is a peer-to-peer network with workers doing this. And then you have the users that are submitting transactions to this blockchain or reading off values of this blockchain. And to make it easy, now you can think about this in terms of Bitcoin and this financial chains, which is, I guess, most easy to explain in some sense. So I will be using that as an example here. So a user submits a transaction. It could be a payment in this case to one of the workers, and the worker will validate that transaction, look at the amount that this user has in his wallet, basically the account balance, and see if it's possible to do this transaction. And in that case, it will put up this transaction for processing. And the third thing that is the ingredient is the ledger, which is the actual blockchain, where these blocks of different transactions are linked together in a way that makes it very, very hard to change one of the blocks and change one of the transactions later on without affecting all the coming blocks. And that's the sort of the strength of this blockchain, that it's immutable. You can't change it once it has been written down. So these are the three things that constitutes a blockchain: the workers that do the validation and synchronization, the ledger that keeps track of what has happening, all the transactions, and then the users using this by submitting transactions or reading off transactions from the blockchain. So the ledger in itself is sort of the interesting from a more mathematical point of view, because you have these different blocks that are chained together using what's called a hash value. So a hash value very easily is sort of a fingerprint, a digital fingerprint of some data. So to the left here, you see one of these blocks. You have a header, and then you have the previous block hash. A hash value could be like 256 bit, and it's sort of a compressed digital fingerprint of all the data in the block. So the header and the previous block and the data in the block are all compressed down to 256 bit hash signature or hash value, and that's put in the end of this block. And then that hash value is used as the previous block hash in the next block, thereby chaining together these blocks, so that if you want to change data in a previous block, then this signature function, the hash function, will be changed, or the hash value will be changed of that data. And because of that, it is linked to the next block. Then the next block will also change, and all the future blocks of this blockchain will change just because you changed one transaction in maybe the first block. Now, if it's very hard to calculate these hashes, then this makes up the immutability property, because if you change the first block and then you can't calculate all the new hashes of the following blocks in a correct way, then everybody will know that you have changed one of these blocks, and your fraud or your attempt to change the history will be obvious for everybody participating here. So this is the sort of the fundamental idea behind the blockchain, that it's not possible to change the data once you have entered it on the blockchain. And this is of course very good for the Bitcoin example, where you record transactions. So I pay somebody a certain amount, and that payment, that transactions, is put in the data field of one of the blocks. And if I later think that, well, maybe I should use that money for something else, which is called a double spending problem in this case, I will not be able to go in and say, oh, I didn't pay you $100, I only paid you $50, so I actually have $50 additional on my account. That's not possible. So this is, of course, one of the fundamental ideas or fundamental properties that we need to have in a financial blockchain situation, but also in other situations where we like to have an immutable trace of what has happened. So how does this hash work, and why is it so hard to make a new block hash? Well, in the Bitcoin case, we're using an algorithm called proof of work. So you can see these hash functions as some kind of a funnel where you put all the data in, or maybe a meat grinder or something. You put all the data in your funnel, and out comes 256 bits, almost random looking bits. Now, in the Bitcoin case, you need, and this is one of the important functions of these hash function is that it's relatively easy to calculate the hash function out of a set of data or this block. But if I give you 256-bit hash value, it is almost impossible for you to find a data block that corresponds to this hash. So if I give you sort of the top thing and ask you to calculate the hash function, it's very easy. But if I give you a hash value and ask you to, well, give me a block that hashes to this value, it's almost impossible. And so to make it even more difficult, it is in the protocol of Bitcoin specified that these hash function or the hash value that you calculate should have a certain number of prefix zeros. And then in order to achieve that, you have to change things in the block, because a fixed block will only hash to the same value every time you hash it. It's a deterministic process. But now if I tell you that you have to have 5 leading zeros in this hash, then you have to change the block so that you change something and you calculate the hash function and you look at the result. Do I have 5 zeros in the beginning? No, I don't. I change something and then you calculate it again. And this takes time. This is the work that is put in trying to find a block that actually hashes to this amount of prefix zeros. And the more prefix zeros we have, the harder it is to find. This requires a high amount of energy to reach, to find this block. And the consensus algorithm, because everybody, all the workers in this peer-to-peer network has to have the same view on those transactions that are written to the blockchain. So how do you do that? Well, there's basically a competition, a race to find such a block with 5 or more or less, I mean, a number of prefix zeros for a specific block. And the first one that finds a block that matches this will be the winning worker. And that worker's block of transactions will become the next block on the ledger. And also, that worker, in the Bitcoin case, the worker that finds this will get a reward. A number of Bitcoins will be rewarded to this worker for finding the block. And that's the incentive of trying to, or the incentive of putting down so much energy and effort calculating these blocks, the hashes of the blocks. So that takes a huge amount of energy. And you can see in this graph here the number of hashes that are performed on Bitcoin. And currently we're around 110 million tera hashes per second. So that's about 10 with 20 zeros after number of hashes per second. And trying to find blocks that matches these the leading number of zeros that are required. And the more hashes, I mean, if you put a lot of workers trying to find these, and then you probably will find such a matching hash faster. But the protocol of blockchain or Bitcoin then is to increase the number of zeros so that it gets harder and harder to find these blocks. The more work you put into the chain, the more zeros you need to find. And the protocol states that it should take about 10 minutes to find a correct hash for any given block. So that's the reason that you can, even how much work, or if you put more and more work into this, trying to solve this and trying to be the first one to find, the blockchain will react by making the problem even harder. So that's kind of an interesting property. So this what I've described now with this proof of work kind of consensus algorithm is what's called a public blockchain, and that's what Bitcoin and Ethereum and all these monetary blockchains are. And so in that case, the workers or the miners that these workers are called, and anybody can join Bitcoin and become one of these miners, try to find the hashes and get the reward. And all of the participants in this in the blockchains are anonymous, both the miners and users, at least to a certain degree. There is no authentication, there's no logging to be able to use a Bitcoin blockchain. And as I said, the consensus algorithm to build the new block of the blockchain, it's a competition to solve this very difficult problem. And that takes a very high energy consumption to do that. Well, on the other hand, we can use the exact same structure of a blockchain, but instead of having anonymous participants, we can have authenticated and identified participants of the blockchain. And then it becomes something what we call the permission blockchain. So then in that case, everybody knows who everybody else working on this blockchain is. And in that case, you can use a much lighter consensus algorithm. There are very, very good algorithms to reach consensus in this kind of peer-to-peer network. So that doesn't take almost any energy at all. And you also have the benefit of if some transaction on the blockchain is kind of strange or maybe even changed or something, since everybody is authenticated and you have a idea of or identification of everybody that's working on the blockchain, you can easily spot who's the perpetrator and who did the change of the blockchain. So that's sort of the price you pay for having a light or low energy consensus algorithm, is that you have to identify yourself. You have to be non-anonymous on the blockchain. And of course, in the Bitcoin case where you deal with money, one of the properties that you would like to achieve is the same as with cash. That, I mean, I can pay with cash in a shop without revealing my identification. That's one of the great benefits of cash today. So what the public blockchain is trying to emulate or simulate is this cash handling. But on the other hand, if you just change the prerequisite that you're not anonymous anymore, then the whole structure of this blockchain or the properties of it change radically. So what you can use this blockchain, the public ones for, you can in my opinion, you can only use it for two things, basically. This on-chain currency like Bitcoin or other things, or you can provide a timestamp of certain information in the blockchain. But this permission, this one you can track real world assets, because you're identified when you put a transaction on the chain. There's an identification of who you are, and that can tie you or the things that you put on the chain onto real world assets. If you're anonymously putting things on the chain, like maybe land has been proposed to use Swedish land registration, property registration. But anybody can put, I own the complete Dalby village, and since you're anonymous, nobody can sort of verify or oppose to it. So for logistics, we need to use this permission blockchain. And it has been proposed in many situations that you actually use this permission blockchain. And I think for some cases it could be very good. You can use it for parcel tracking, goods monitoring, and also put contracts and in some sense solve disputes around contracts and payments in this blockchain scenario. And I'm going to talk a little bit about this. So now we're not particularly focusing on packaging, but more on parcels in this case. So if we go to parcel tracking, today we have a system which is more or less based on checkpoints. You have either barcodes or RFID readers or transmitters that you can, as soon as the package come into a distribution central, you scan the barcode or the RFID tag, and then the system knows that, okay, at least the package has arrived this location, and then you transport it to a new location, and then it's read again, and you say, okay, I have another checkpoint here. So that makes it easy. It's pretty cheap packaging, but it's manually dependent on people scanning, or at least you need to in some way scan these documents actively. And it's quite easy to lose parcels in this process. I think we have seen that in the Swedish Postal Service, PostNord, a couple of times in the news. And it's also pretty easy to clone. If you have very valuable things, it's really easy to take a photocopy of the barcode and put it on another parcel and just ship that one away to the destination, and nobody will know where that actually happened, that swap. So on the other hand, if you can use a continuously tracked parcel tracking system where you have, for instance, a Wi-Fi or a 3GPP mobile network kind of transmitter where you continuously track the parcel while it's in the distribution center, or at the warehouse, or on a lorry, on a ferry during delivery, that would be much harder to clone, for instance. And you will also get the parcel location by design, because this will transmit your location, approximately your location at least, continuously throughout the delivery of this package. But of course, this more expensive packaging, you need to put in a small Wi-Fi modem or a mobile network modem into your package. And you have to also have infrastructure support. In the case of mobile networks, you pretty much have global coverage, and ferries or shipping industry can solve that with local base stations on the boat and so forth. But it's of course more expensive to do this. But both these techniques can go into a blockchain where you record that this parcel is now at this location, and that information is then immutable for everybody to see. So from a blockchain perspective, it's just sort of collecting information and different things, but these are things that you can think about. Now, another thing that is very nice with this is that you can do goods monitoring very easily. If you have sensible products for temperature or different kind of accelerations, humidity, and also sealing in some cases very important. But this requires a very tight coupling between the goods container or the package that you put the goods in, and the sensor and rapporteur of this, the logistics setup. So this also requires very strong identities for the parcel or the package, because otherwise it's very easy to for instance, try to if you have something that is sensible to temperature, then you can just spoof the temperature reporting to the blockchain by if you don't have a strong identity of the sensor. So in this case, if you want to do goods monitoring in any way, it's very, very important that you have strong identities, the strong identification of which parcel is which and which container is which, and then you have good credentials like passwords or certificates for that parcel. And something else that has come up quite often in blockchain logistics is that you say, oh, we can make sure that this food is organic, and we can make sure that it's genuine medicine, and all that just because we're using a blockchain. And that's completely nonsense, of course. Because the information that you put on the blockchain is only as trustworthy as the person that enters it. So, whenever you have these off-chain events, like you're claiming that you grow something organic, or you're claiming the medicine is genuine, then somebody has to enter that information on the chain, on the blockchain. And I mean, if that person or that process is not monitored and has an insurance, then the information on the blockchain is of course nonsense and useless in that case. So beware of people that are trying to sell blockchain solutions to you that really say something about off-chain events, because it's ridiculous at the best. And the last thing I want to talk about is contracts and dispute. And for many of these blockchains, you can also have what's called smart contracts. And smart contracts is just software that is run on the blockchain. And that software can be checking that certain events has happened, such as delivery to a specific destination, or that you have paid a certain amount at a certain thing. So in some sense, you can use these contracts it's very efficient and sometimes very good, but you have to remember that that this is software, and you know, software, it's full of bugs every time. So and some people claim that, well, you can change legal signing of a document to a blockchain contract and you will have no problem at all. It's airtight. The blockchain will just, you know, perform perfect. But again, there's a lot of bugs in this, and we've seen that in the history of blockchains that has actually happened. Serious bugs in contracts that people have lost a lot of money on this. But on the other hand, you can get a very clear history of events in case of dispute. If you record all these information in an immutable blockchain, then it's very easy to go back and verify that things happen, and then you have maybe a stronger case when you have a dispute with somebody. And then payments, you can choose to have sort of on-chain payment where you pay in the currency of the chain. You can tie a chain to this, but you can also have off-chain payments like you have normal banks. But one of the things that you have to, if you look into this kind of logistic with blockchain, you have to very carefully look at the governance of the blockchain, because we have a permission blockchain. Everybody knows who everybody is, but it has to be run by somebody, because there's no incentive of the open source or any other community to run it, because there is no monetary payback as in the Bitcoin case. So for instance, in the IBM and Maersk blockchain for shipping industry, this was a bit of a problem in the beginning, because Maersk owned all of the APIs and the blockchain itself. And the competitors didn't want to join this effort because it would only, you know, give Maersk additional income. So this is something that you really need to pay attention to if you're thinking about using a blockchain for your logistics. So to conclude this, first of all, make sure that you really need a blockchain. In many cases, you don't. But if you really want to go for it, or maybe you want to do a pilot, you can do it. And be aware of the very different properties of these public and permission blockchains. If you go for logistics or packaging and tracing and so forth, you need to go to permission blockchain. And there is a need for strong digital identities for goods and parcels to make this fly, because otherwise the information that the goods is sending to the blockchain is easily spoofed, and then the information is worthless on the chain. Smart contracts, it could be efficient, but remember, it's still software, so don't let anybody fool you about that. And also think about the trustworthiness of off-chain events, like this. I told you, the organic food, tracing of organic food. It doesn't really mean anything because the organic part is happening off-chain. So that's my take on blockchains in logistics and some of the things I think you should.
Thank you so much, Patrik. We have run. This was really interesting, and I think it is a lot of thought-provoking things in your heads. We need to hold the questions for later, and I would like you to either keep them, write them already now, and Patrik, you can also, of course, look at the chat and answer them directly there, but we will bring them back later on if we have time. So thank you so much for this.
My name is Carl-Ludvig Svensson, and I'm an industrial designer by training, currently building my own studio practice focused around the role of materials within product design. Materials and processing methods is by no means a new field of focus within industrial design. However, methods of exploring materials' expressive and sensorial dimensions have led to the belief that business opportunities can be found in looking differently at the materials a company has to its disposal. I'm joining you here today to give you a glimpse of an ongoing project with the ambition to upcycle a monthly volume of 54,000 cubic meters of biomass. Generally speaking, we all are now quite well informed of the value that can be harvested in waste streams, but nevertheless fully aware of the costs to process and prepare these resources. For my collaboration partner, a large Swedish sawmill group, the problem was water. Water used for cooling the saw blade in the process of preparing construction timber, resulting in a vast amount of moist sawdust that, due to its high water content, leave them with a biomass of poor energy recovery possibilities that consequently retails at a low price on the market for bioenergy fuels. But water and lignocellulose biomass turns out to be the perfect breeding ground for fungi, and that is a material. By introducing a fungal culture to the moist sawdust, the organism will feed off the lignocellulose and form an interconnected web of hyphae called mycelium. Let's zoom in a little bit here. This network will bond the particles within the biomass together, much like growing a glue. The mixture of mycelium and sawdust can either be grown into shape using a mold or pressed in regular wood compression molding equipment to receive its intended shape and with various surface properties. This opens up a plethora of possible uses. The material properties in a non-compressed state is somewhat similar to expanded polystyrene, which is bought in large numbers by a subdivision of the sawmill group that undertakes internal transports of a Swedish truck manufacturer. Using a custom-made expanded polystyrene insertion buffer placed inside a wooden structure to serve as a packaging for the truck components. So, what if we could replace this styrofoam with our self-grown mushroom material? Producing packaging materials from mycelium is a relatively new field that is currently being exploited and developed by a small number of companies. The founding idea with this project is to geographically connect the production line to where the waste stream is produced and incorporate this new area of business within the company structure, rendering a vision of a more efficient use of resources, less dependency towards subcontractors, and first and foremost, saving energy per every unit of styrofoam not used. But we're talking about a naturally fueled growth process. So how long does it take? Initial tests done in collaboration with a microbiologist have shown that parts can be grown in 1.5 weeks. However, there is technology available that promise a shortened growth time down to 4 days. In any case, this is much faster than conventional farming. Simply put, it requires time and space instead of investment-heavy processing equipment and expensive fossil fuel-based feedstock. And this is why it's a promising technique to use in connection to a sawmill. As you can see, there is room for some extra housing that could facilitate a growing space. Let's have a look at the top left corner here. Here you find the shed marked by the gray ring, where all the sawdust is collected. In the long rectangular building, slightly lower down, further to the left, you see the kiln, which is the drying machine, where the lumber dries to suitable humidity by hot air fans. This structure generates temperatures as high as 90 degrees Celsius that is continuously flowing through the wood and outside the structure, 24 hours a day, 7 days a week. In connection to this source of heat, generous growing conditions for fungi can be met. Another consideration that needs to be taken into account is the sterilization of the sawdust, which is needed to get rid of organisms such as molds that could potentially compete with the fungi culture when colonizing. Here, traditional sawmill equipment such as an autoclave for impregnating timber can be used. See the white ring. So let me give you a short run through here. Mycelium can bind biomass particles together. It can be shaped in many ways directly through its growth process, reducing the need for post-processing. Scalable operations, no commodity shortage, and first and foremost, environmentally compatible and home compostable. So, thank you very much for listening.
Thank you so much, Carl-Ludvig. It's really interesting, and please use the chat here for some questions. We do have time at the moment for some questions. I have a question directly for you, and I want to know, you are coming from the industrial design area and have quite some other perspective maybe. We have been talking before about a bit of the complexity and the challenges in actually working together and understanding all the parts and bits in it. What would you say when you are stepping into this? What are your main takeaways, and what would you see that you could add into this sometimes very complex discussion?
Yeah, I mean, for me, generally speaking, from my side, I think it's very interesting to meet these sort of very technical requirements from a more generalistic standpoint, so to say, and really put the puzzle pieces together, bridging different competences and also goals and needs, right? So yeah.
Thank you for that. We do have some questions here. How are you sterilizing the sawdust?
Yeah, so the idea here is to use the autoclave that it's used within at the mill, at the sawmill, yeah. So autoclave and yeah, pressure.
Okay. Is that a good? Was that okay? I'm now I can actually look at the call in real life, so I'm looking at him. He nodded and said it was a good answer. And from Dog, do you need to kill the fungus?
Yes, you need to do that, and that is also a matter that where you can use the kiln. So the drying machine for the construction timber, and here you have different possibilities. You can work with time and you can work with temperature. So so here you have to sort of set up perfect conditions connected to the amount of material that you process, basically.
And we have a final question here. Can you use other material and not only sawdust?
Yes, you can. You can use all the lignocellulose biomass materials. For example, you can use agricultural waste, and there are some companies, especially in the US, working with that as a source. Here in Sweden, we have our great forest industry, so sawdust is an interesting raw material here.
Okay, so thank you for that. We will maybe come back to you during the Q&A later on. But as now, thank you so much for this presentation and sharing your experiences and great innovation in this. So I will go on to our last speaker, and it was in the invitation we had 2 speakers from Scanfill, but we actually just have one. And Oscar Hugoson, Executive Vice President at Scanfill, will talk about how to reuse. And so welcome, Oscar, to the screen. Are you there? I can see you.
I can see you.
Can you share your, thank you. Can you share your screen? And I know maybe you just want to tell because you have a lot to do presently, I think. Maybe that's
yes, we are. Yes, we do have a lot to do. Can you see the screen now?
Yes, absolutely.
Yeah, Pontus was supposed to be with me today and present with me, but he's in the factory producing. We are one of the fortunate ones to be producing at full capacity at the moment because we've gotten new orders for PET film for visors for the healthcare. So we're trying to do our best and keep them safe, which I'm kind of proud of. So it's a good thing he's not with us today.
Good for you. Good luck.
Thank you.
So,
well, yeah.
Screen yours.
Can you see it?
Yes.
All right, cool. My name is Oscar Hugoson. I'll be talking about how to reuse and recycle today. First, I'd like to introduce the Scanfill company. It's a part of the Polychemy Group. We turn over about 130 million euros, 2018. We're completely family owned. We founded the company in 1968. And we're about 300 employees worldwide. About 220 of them are in Ystad, where our headquarters is. Hondo Plastic is one of our subsidiaries. Scanfill, which I'm representing, is another one. And Polychemy China is another one. We try to say that we're a local producer, but a worldwide supplier. That means we have a production site and headquarters in Ystad, in Sweden. We have our own production in China, outside of Shanghai, and we have production partner in the US. Subsidiaries across Europe, agents across more of Europe, and we work on markets all over the world. Scanfill, let's see here, there we go. Scanfill is doing packaging material based off plastics. We have the regular Scanfill, Scanfoil, Scanfill Bio, and Decafil. These are different kinds of materials that we customize for different kinds of production possibilities, either extrusion blow molding, film extrusion, or whatever the customer is using. The materials we used are from a very wide range of polymers. It's everything from oil-based to bio-based, from degradable and non-degradable. Most of the plastics that we use, though, are the oil-based and non-degradable, the regular PP, PE, or PETs. The main product has been for a long time for Scanfill the regular Scanfill, where we've had mineral reinforcement material in it. And a lot of customers and people ask us, how is it possible? Well, It comes from the mother company, Polychemy, who's been doing compounding for over 50 years. That means that we're mixing materials, polymers with reinforcement materials, additives, pigments. We're basically customizing the products that we produce according to our customers' needs and wants, what they need, and we're solving problems, and we're coloring it in the perfect color for them. Enough about us. What I'll be talking about today is the reuse of plastics, how you recycle and how we think and what we do when we reuse plastics. What I'm showing here is an illustration from Rustan Nilsson at Sysab. It's a great illustration of how we think in the market of how plastics should be or how it should be thought of. Reduce the use of plastics, reuse it, and recycle comes third. If you look at the European Commission triangle, recycling is third as well, but it's actually one of the biggest topics and the hottest topics on the market at the moment. What we think is reusing plastics and recycling it is what we should be focusing on most and prioritizing, not being the third step in the hierarchy. Some of the plastics that are used in the market are shown here, especially in Europe. What we can see is that the packaging industry uses by far the most plastics in the EU. The most common ones are the PP and PE polymers, the polyolefins. Other things that stand out is that PET, for example, is almost only used in the packaging industry. Most likely because it's got a closed loop for PET bottles, for example. But what really stands out in this diagram is that the PP materials. They're used across all industries and is the single most used plastics in the market, in the polymer industry. And if you take a look at the recycling of trace in the packaging industry, we have multi-layer plastics. Most of it goes to incineration. PET, most of it actually goes to incineration, and we're talking about trace. PLA, most of it goes to incineration. Some of these goes to landfill as well. These numbers are from the Fraunhofer Institute in Germany, so it's, for me, very reliable information. But if you take a look at PP trace, most of it, or half of it, I should say, almost goes to recycling. And it's the only polymer that's being recycled at the moment. Very interesting where we should put our thoughts, referring to the previous picture of the most used plastics, and for this case, PP trace being the only one being recycled. If we take a look at other ideas of what we focus on at the moment, carbon footprint. PET has a really high carbon footprint per kilo of plastic. Virgin material, the zero column, has quite a bit of carbon footprint for PET. PP's got somewhat lower, and when you polymer reduce by using fillers, such as all kinds of minerals, to reinforce material, you get a much lower carbon footprint. This is good for both the packaging industry, but actually for all of the polymer industries. You reinforce it and you use less plastics. What's interesting is that you have to recycle PET 6 times to get lower than the Scanfill material. You have to recycle PP 2 times to have a lower average carbon footprint than a virgin material of a polymer reduced reinforced material, PP material. Something to think about when we go into the case later, where we put this concept into actualization and made very nice furniture of this kind of material. If you recycle Scanfill or polymer reduced material, the CO2 footprint is way lower than most other competitive materials in the market. If we talk about recycling, circular or spiral, well, we run into a challenge. Post-consumer waste is a big challenge at the moment. It's difficult to make circular for food packaging. And that's mainly because of the food safety, the hygiene and legal requirements on traceability. We don't really have a great way of cleaning PP materials today to make it a packaging worthy material. But we have other production possibilities to make it a good material. Circular, bottle to bottle, everybody knows how that works. But a spiral economy is where we recycle, downcycle, and upcycle material. We usually hear that recycling material is downcycling. We don't downcycle material at all. We use trays and make designer chairs, which can be recycled into a car part. And I wouldn't put my kids in a car where I knew the material were not up to par and the specifications according to the plastics specifications for that automotive producer. So just keep that in mind. Recycling is not necessarily downcycling. It could be upgrading the plastics for more advanced parts. Quickly, spiral economy. You produce, you use, and you recycle material. This is a circular economy. But that, like you saw before, is not actually happening. We incinerate most of the packaging today. But a spiral economy works this way. We take a tray, we produce a car part, and we recycle the car, which is actually possible today with today's technology. And we produce a flower pot, for example, recycle that one and produce a designer chair. Something that I'll be speaking a little bit more about next. And this is a spiral economy. It grows bigger and bigger, and you reuse the plastics where it's needed and wanted. A tray doesn't necessarily have to be a tray. What should be thought of is not keeping a closed mind. The packaging industry doesn't have to solve this problem by themselves. The plastic industry needs to solve this problem altogether. The case we have with us today is a Flock case. They produce office designer chairs, and they've used recycled plastic material for a long time. They started in 1995, producing out of post-consumer PP caps their first chair. This chair has been a project worked with us, and it's the first chair that's Svanenmarked. It's Svanen certified in Sweden. It's a combination, it's a collaboration and all of the plastic details in this chair, recycled material. We've also used a lot of post-consumer waste, even though it's a designer office chair, something that maybe one of you in the audience are sitting on today. This is a great case of how spiral economy works and how we should think about recycling materials. Their history has been long. Since 1995, they've thought about and they've developed the use of recycled materials. The last few years, they've used a lot of recycled materials, up to 649 tons last year. 2020, they have a goal of using 800 tons of recycled material, and 2021, they have a target of using 1,000 tons of recycled plastics. That's a great goal, and that's what everybody should be aiming for within the plastic industry. Just to show you some other examples of what they have done. These are some of the examples of the details that they have in their assortment today, where they use recycled polypropylene. Some of them are under assessment, and some of them are not possible at the moment. But I can assure you, We work really closely with this company, and our goal together is to use as much RPP as possible. So what should you take with you today? How to reuse? Well, the packaging industry needs to understand and realize that the reuse and the recycling of plastic material within the packaging industry cannot be solved within the industry. It needs to be solved using a spiral concept. We need to use that, and we have to collaborate across industries to think, how can other industries use our material? And we have to talk cross industries to solve this problem. We usually say, don't let the value go to waste, because there's a lot of value just floating around in many ways. And this material can be used and recycled into great projects like I've just showed you. A great case that's been done and being done at the moment. And I think we all should follow lead to what Flock and the Hogue concept has been doing for the last 25 years. Thank you very much.
Thank you. Oh, I lost my voice here. Thank you, Oscar. That was really a fascinating presentation. And again, you're addressing the questions that we have seen here during since this morning about actually starting to talk to each other and bring on some further understanding in the different value chains. To this, I want to, we have one direct question to you, Oscar. How does the FTI recycling in Sweden work with your material?
We have plenty of materials. Some of them are filled, some of them are unfilled. The filled materials are fully recyclable or sortable in FTI's machinery today. Once they've sorted our filled material that has a higher density, when they sell it or send it to Germany, who will actually clean it and density separate the materials, it will sink and go in the other stream. So yeah, the regular polymers, the Scanfill, for example, are fully compatible with FTI's recycling guide that they have designed.
Okay. And another question here, how about hazardous substances in plastics, their impact to circularity?
Hazardous substances are, well, in the circularity, that's the main challenge the food industry has, because it cannot migrate any hazardous substances into the food stuff that we put in packaging. That's also one of the challenges that we have with recycling post-consumer waste into packaging material today. What can be done in the future? Not completely sure, because there's a lot of development going on. What I do know is that we can work with layers, just like the PET bottles. They have recycled material in the core, and then most of the bottles have a virgin layer on the inside and the outside, keeping the bottles safe.
So thank you very much for that. So what we're going to do now is just opening up the more open Q&A session, and I want all of the speakers to be on their toes, because we might just address the question to you. So please, Katrin, Peter, Dag, Patrik, Carl-Ludvig, and of course Oscar, be there and have your sound on and unmute and picture on, video on. I would advise you all to have actually the video on, because now we are looking at least those of you that have your video on. So it would be nice to kind of feel that we have all these people in the room. But as a little bit of assistance there, I want to welcome up again Marie and Carl to help me with this session. So please enter the stage again, and we will have a bit of an open Q&A. So use the chat again and start asking questions. I would ask you, we have a lot of really interesting presentations, quite some different aspects, and obviously the challenges. What would you say that the best takeaway from today is? Right.
I would say, as I said in the morning, it's still that we need to collaborate in the value chain.
Yep.
We cannot sit in our silos, a bit like Katrin was talking about. We cannot just look at one part of the process, but we need to look at the entire process from the raw material all to the recycling. So I think that's we need to collaborate more.
Carl, what do you?
I totally agree. To in this way turn and see all of the sides of the value chain and all different aspects of this huge area is just to inform everybody about that is really relevant.
I know that when we talked about the blockchain part with Patrik, we didn't have that many minutes for questions, and I do know that there were some questions just for that part. Would you see, when you listen to Patrik about this, is this something that we could use more in this industry to kind of find new solutions to, or how can we use it, even if it's complicated?
Is it a question to...
Yes, I will ask Patrik as well.
Yeah. No, let's start with
yeah, Patrik, do you hear us? Where are you? Where are you?
He's the only one out here.
No, Patrik. Okay, so we'll leave him at the moment, and we might get back to... Okay, he's... rejoin. Let's just hold that for 1 minute, and we will have this question that we have in the chat. It's what is the take on the EU's Green Deal journey? Is there anyone who wants to, from the speakers, who wants to answer that? You can raise your hand. I will see you. Katrin, do you have any questions, answers to that? Do you? You need to unmute yourself if you want to start speaking. Katrin?
Yeah, no, I mean, it's for the packaging industry, as we have talked about today. I mean, there are a lot of interesting opportunities to try to see how we can switch from fossil-based materials to renewable materials, and I think it's that is both an exciting thing, but also a challenge, especially with regard to the barrier requirements that many of the speakers have been talking about today. So I don't know. I don't think it's I think it's a good thing, but that there's also politicians behind this driving it in the same direction. That also gives more clarity for the industry on what is the direction that we are going to. But at the same time, it's not an easy thing to solve for food packaging.
Okay, so now we've met. We see that Patrik is back. I asked a question about the blockchain technology that you were talking about before, how that could actually help this industry. Do you have any additional thoughts on that, Patrik? We can't hear you. We can't hear you. You are unmuted. So it's something in your... I know, Hanna. Now it's muted. Try. If you say something now. No, no, no. Okay, this is always interesting, and especially when you're just standing here. I can't do anything. No sound. It worked perfectly well before. Okay, we'll leave it a bit, Patrik. We'll come back again. Maybe it will help. We have another question. Will the COVID-19 affect the speed for changes in the industry? And here I think maybe a lot of the speakers have something to say about that. Anyone wants to start? Raise your hand and unmute yourself. That's a good one. Nobody wants to say anything. Yes, dog. You need to unmute yourself though. Yeah, you can talk now.
Okay. In my mind, the strive to improve packaging has already started, and maybe it will have a small effect on the general public's view, but I don't think it has a great effect. No, not in my view.
No?
But I think the move is already going, and it's already on the way, and I think the strive is already very strong. So I don't think that necessarily is a bad thing, but I don't think the COVID-19 has a great effect. Maybe a little bit more focus on buying local and accepting different solutions, because I think that is one of the, it's not only the technical part, it's also accepting that one solution does not fit all the problems, and that might be easier now with a general acceptance of that there is many challenges that we need to face, not only looking for how to put food on the table.
Okay, I think Oscar, you had some, you need to unmute yourself as well.
I think there's an interesting thing to look at. Plastic packaging has been looked upon as something that we don't want or don't need. If you take a look at, for example, the industry of takeaway, it's been booming the last few weeks because no one's eating out. Everybody's eating out, taking away food from the restaurants and bringing it home. Our production has boosted that part of our orders, and plastic packaging is not looked upon as something really bad for the last few weeks. We're actually increasing packaging for the hospitals and that segment as well, and it's saving lives. We're not talking about that part, so it will change. I think we will look upon plastics in a different way. I'm not saying it should be in the ocean. No one wants it in the ocean, but I think the conversation will take a turn of how we will use it and what we will think about it. So, yep, there will be some changes. Using bio-based material, not necessarily. I don't think that's the solution in the short run. In the long run, I mean, 20 years from now, maybe, that will be the majority of the plastics. I'm not sure because I don't see too much of a difference at the moment, and still pricing is the major reason why we're not using it. So COVID will make changes, but not necessarily what we all dream about, because it all comes down to the economics of everything.
But do you think, just in addition to that, would you say that this will bring on, I mean, we've been talking here a lot of the need to talk to each other and actually find new solutions, and we need that in any ways, but in kind of normal life, we're just running around in our own bubble. But now maybe there's another now that we are forced to actually find new solutions, but for different reasons, and maybe that will also help us to talk more in the future, so to say. Do you, I'm addressing that to you, Oscar, because since you were a little bit on that note.
I hope that we can collaborate across industries much more than we've been doing lately, or so far, I should say. Because each industry is looking to see what they can do and get their numbers boosted to say that we've been doing a great job. The plastic industry should be doing a good job together and boost their numbers, and not just each industry within the plastic industry. Not really sure what you're looking for in an answer, but I do hope that recycling is a hot topic that will be a major thing to discuss from now on, and I don't think COVID will change that, to be honest. I think it's just a hot topic at the moment.
Patrik, I think you might be on board now. Are you?
Maybe
Oh,
not.
yay!
I don't know.
So my question.
Okay, so hit me with the block.
Well, it was a question earlier on, and I don't have it in front of me, but I know that it was, I mean, or I was asking you if you see how blockchain actually could be used to make the whole packaging industry more efficient of what you have.
First of all, I'm not sure that you necessarily need a blockchain, but I think that in a setting where a lot of different participants or different companies are involved in the transportation or the parcels sort of life cycle in some way. I think it could be good to use the blockchain in that case, but then I mean, these permission blockchains are not really that different from a distributed database, like any distributed database that you could build. So the specific use of blockchain might be questionable, but sure, it works. It works. It's like the Danish transport company Maersk, together with IBM, they have a big, maybe it's not a pilot anymore, but they have a big blockchain running for tracing containers all over the world, with different ports and different shipping industries involved in this. And I mean, it seems to work. What the benefits are by using a blockchain instead of a distributed database or a central database is maybe questionable. I can't answer that because I don't know the exact way they run this. But sure, it could be useful, especially if you want to have a public verification of things, where you can verify or read off things to chain, where you don't have to authenticate yourself. You only authenticate when you read or when you write information to the chain.
Yeah. What do you say about that? Could that be interesting for the industry?
Well, I guess that using a blockchain comes with a cost. Maybe it's the same cost as you have for a database, but so if it's the similar cost, then why not?
Yep.
Yep. So, do we have any more questions from the audience? We have some few minutes left on this. Again, I would. You can use this chat. You can tell us now what it brought to you, what your takeaways are, if there's any takeaways to us to think about till next time. What will happen next? What are you doing with all this great information, daily life? What are you doing?
Well, I hope that some of you will reconnect either with us or with each other for further chats or collaborations or whatever. And if you need contacts to anyone, send an email or call us, because we don't share.
Absolutely. Yeah, just contact us, call or me, and we will forward some information to you.
And we have some, the last slide, it was the websites for Modéer Business Center and for Packbridge. So use that. So I think we will end here. And thank you so much.
Thank you so much.
Thank you.
Thank you for all you.
Thank you. And I think we should all
really well.
And I think we should all remember that we are simply stronger together.
Exactly. Even though we're like this, but we are still together, right?
Together. Exactly.
And then we have a thumbs up. I like the thumbs up. Use the mimics of whatever you have and thumbs up. Thank you. Thank you for all the speakers. Thank you for using this technique here, and go out and do all those good things you're doing. Thank you.
Thank you.
Thank you.